Thanks for watching this screencast. The objective for this screencast is learners will be able to divide polynomials by long division. So in class before this screencast, we talked about polynomials, we added them, we subtracted them, and we multiplied them. What we didn't do is divide them. So in this screencast, you're going to see the process by which you can divide polynomials, and it's actually very similar to the long division process you learned in grade school. So we'll model one for you here. What we want to find is the quotient of these two polynomials. We want to divide x to the fourth minus 11x cubed plus 35x squared minus 13x minus 60 by the binomial x minus 5. So I've set it up much like you would a long division problem that you learned many years ago. The quotient will be found by taking the dividend, the polynomial that we're dividing into, and dividing it by the divisor. So if I think back to that process I learned in grade school, what I thought about was, well, how many times would this go evenly into this? How many times would the dividend accept the divisor? Another way to think about it is like, what can I multiply by the divisor to get the dividend? What can I multiply by x to get x to the fourth? And the answer is x cubed. So that's what I'm going to put right here. The first term of my quotient is x cubed, because x cubed times x would give me x to the fourth. Now, what you did once you put a number that stood for one of the numbers in the place of the quotient in grade school was, you said, let me multiply that by the divisor, and then we'll subtract. And that's exactly what we're going to do here. So let me multiply x cubed by x minus 5, and let me put that right here. X squared times x is x to the fourth. X cubed times 5 is negative 5x cubed. And what you did next is you said, well, let me subtract. So let's do that. If I subtract everything here, you know, if I've worked the problem correctly, this should be 0. X to the fourth minus x to the fourth is 0. Might want to be careful here with negative 11x cubed. You know, if I make this a plus sign, this would be a negative and a positive, wouldn't it? So this actually helps me see that I think that I've got negative 6x cubed when I subtract. And what I'll do next is I'll bring down the next term, the plus 35x squared. And what I'm looking at now is running through this process for a second step. So now I want to say, well, what can I multiply by x to get negative 6x cubed? And the answer is negative 6x squared. And now I will multiply negative 6x squared by both of these, and I'll place them right here. So negative 6x squared times x is negative 6x cubed. Negative 6x squared times negative 5 is a positive 30x squared. And I will subtract those. Subtracting those makes this positive and this negative. So these cancel, and 35 minus 30 would give me 5x squared. And now I'll bring down my negative 13x. So here we go with the third round of this. Now I'll say, what can I multiply by x to get 5x squared? It's a positive 5x. So 5x times x is positive 5x squared. 5x times the negative 5 is negative 25x. And I'll subtract. And in doing so, this would become a positive and this is a negative. So these cancel. And negative 13x plus 25 is a positive 12x. And I'll bring down my negative 60. So this is the last step of the process. What do I need to multiply by x to get 12x? 12. So if I multiply 12 by x minus 5, look what happens. I get 12x, and 12 times negative 5 is negative 60. And thankfully, when I subtract this, what I get is 0. That's my remainder. Remember when you were doing long division that once you made it all the way through the process, whatever number was left was your remainder. So this is my quotient. This is my answer right here. What do I get if I divide x to the fourth minus 11x cubed plus 35x squared minus 13x minus 60 by x minus 5? I get this. X cubed minus 6x squared plus 5x plus 12. Okay, here's one for you to try. You should pause the video on scratch paper or somewhere where you can work this out. You should try to find this quotient. And when you think you've got it worked out, hit pause again, or I guess hit play, I should say, and check it out. Let's start this in by saying, what would I need to multiply by x to get 2x cubed? Well, 2x squared makes sense, because 2x squared times x is 2x cubed. So let's multiply 2x squared by the divisor. Let's say 2x squared times x is 2x cubed. 2x squared times a negative 1 is negative 2x squared. I'm guessing if there's a mistake to be made on this, it's somewhere in dealing with the signs, because I need to remember that I need to subtract this. So subtracting this would make this a positive, this a negative, and this a positive. And when I combine those, these cancel, and negative 5x squared plus 2x squared is negative 3x squared. And down comes the 5x. For my next step, now I'm at negative 3x squared. What do I need to multiply by x to get negative 3x squared? Well, it's negative 3x. So negative 3x times x is negative 3x squared. Negative 3x times negative 1 is a positive 3x. And I need to subtract that. So this is positive, and this is negative. And these cancel. And what I have here is 5x minus 3x, that's 2x. And down comes the negative 2. So for my last step, at least in the division process, I need to say, what would I multiply by x to get 2x? It's 2. And 2 times x is 2x. 2 times negative 1 is negative 2. And if I subtract this, I get 0 again. My remainder is 0. That won't always happen. In the two you saw on the screencast you're looking at today, it did. And when we get together in class, we'll talk about what to do if it doesn't. The quotient here is simply this trinomial, 2x squared minus 3x plus 2. A really good way to check and see if you've got the right answer would be to multiply this trinomial by x minus 1 and see that you don't, in fact, come back to 2x cubed minus 5x squared plus 5x minus 2. Thanks for watching.